Okay, good afternoon. Today we're going to be talking about limiting reagents and excess reagents. This is just a continuation of our stoichiometry problems from the last couple of days. So let's get to it. Limiting reagents are reactants that are completely used up in a reaction. When you run out of something, the reaction has nowhere to go. Okay, and so we stop forming product. So if you have two things together and you're mixing them, well, one thing's going to run out first before another, and we call that the limiting. Whatever's left over on the other side is our excess product, and we'll look at that in just a second. Okay, the excess is going to be whatever's not used up. We're going to have extra. The limiting reagent is going to determine, so I want you to take your pencils, the limiting reagent determines how much product is formed, and this is going to be pretty important for us because that's what we're going to be searching for. Okay, this is not in your notes, so you can put your pencils down for just a second. Back to the s'mores thing. We talked about the s'mores a while ago. Let's look at the s'mores in relation to a limiting reagent. So if you have your chemical equation for a s'more, right? 3 chocolate squares plus a marshmallow plus 2 graham crackers equals a s'more. Here's an example of a limiting reagent situation. Okay, so let's say that our friend right here is throwing a slumber party, and they have 127 chocolate squares, and they have 47 marshmallows. Okay, well that's just what they have on hand at the party. So how many total s'mores can be made? So in order to figure out which one's going to run out first, we actually have to do two calculations. We have to do both because we don't know if the marshmallows are going to run out first, and we don't know if the chocolate's going to run out first. Okay, so this is how we're going to complete it. We're going to start with the chocolate squares because that's what's first in the problem. You're going to convert using your mole to mole ratio, 3 chocolate squares to 1 s'more. And that's going to tell us how many s'mores we can make of chocolate. Now, to compare and figure out which one runs out first, we also have to do the marshmallows. So in this case, our ratio is 1 marshmallow to 1 s'more. It's a 1-to-1 ratio. And in this case, we produce 47 s'mores. So out of these two, whichever one produces less is going to limit how many s'mores that you can actually have at the party. So in this case, which one limits our production of s'mores? Well, it's going to be the chocolate squares. Okay, so the chocolate squares here are the limiting reagent. Now, yeah, you have like 1.5 s'mores left, so someone's going to get cut short and they're not going to have a chocolate square, but hey, I mean, I'm cool with that. That's just me, but we are limited. Okay, pick up your pencils. Here we go. Steps to determine the limiting reagent. First, we're going to find out how much could be produced from each amount of reactant. That means you have to do two calculations. I want you to write that in there. You're going to have to do two calculations. Okay, and then whichever produces less is the limiting. Okay, so let's do our first example. Let's dissect our problem. If 6.7 moles of sodium reacts with 3.2 moles of chlorine gas, what is the limiting reagent? How many moles of NaCl will be produced? Okay, so that's what we're looking for. How many moles of NaCl will be produced? Okay, so we need a chemical reaction for this. Here it is. It's written in your notes. Make sure that it is balanced. Okay, go ahead and write those in. 2, 1, 2. And if you want to go ahead and write a 1, sometimes that'll help us out, remembering that that's a 1 there. Okay, underneath the problem, what I told my students was to write out underneath 6.7 moles, and then also 3.2 moles. Okay, and then also how many moles of NaCl? That's what we're looking for. Okay, so here, this is the only difference today, is that we have two starting substances. That's the difference. That's the tweak. So now we just have to calculate both to see which one is going to actually produce less. Which one are we limited by? So we're going to start out with sodium. 6.7 moles of sodium. Let's take our pencils and draw a T-table. I'm going to write over here our stoichiometry diagram. Boom, 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 boom. we have liters, grams and RP, representative particles, grams and liters. Moles are on the middle. So let's check out our route. Well, in this case, we are going moles of sodium and eventually chlorine to moles of the other side, NaCl. So it's just a mole to mole ratio. So let's go ahead and figure out that ratio. The first one for sodium is a 2 to 2 ratio. So I'm going to write 2 moles of sodium for every 2 moles of NaCl. So when my units cancel out here, I have moles of Na on top and bottom. So what I'm left with is moles of NaCl. So I have 6.70 moles of NaCl that's produced by sodium. Let's do the other. Okay, it's 3.20 moles of Cl2. That's chlorine gas. Okay, draw our T table. Make sure you give yourself room there. So now I'm looking at a 1 to 2 ratio, a 1 to 2 ratio of chlorine gas to sodium chloride. So I'm going to go ahead and put that down here. 1 mole of Cl2 is going to yield 2 moles of NaCl. My units will cancel. Moles of chlorine, top and bottom. I'm left with moles of NaCl. When I multiply this out, I'm going to get 6.40 moles of NaCl produced by chlorine gas, Cl2. This one was produced by sodium. So compare the two. Which one's going to run out first? Chlorine or sodium? Well, if I have to pick, it's going to be 6.4 because it's less. So you find the one that's less, and that is your answer. So your limiting reagent would be chlorine gas, Cl2. And that's your answer. Very good. To determine how much is left over, we're going to have to do an additional calculation. Okay, so I want you to pick up your pencils and circle excess reactant, right? So the next example, we're going to find limiting reagent, but then we're also going to find how much is actually left over. So here's our problem that we're going to work through, but before we read through it and dissect it, let's see what we're going to have to do here. Okay, I see 0.5 moles of aluminum reacting with 0.72. So right away I have 2 starting materials. Okay, and I'm going to have to figure out, number 1, how much is produced and how much excess. So first step is going to be finding the limiting reagent. Okay, that way I can actually figure out how much is going to be produced. And then this is our new step here. Our next step is going to be finding how much is left over. We call it the excess reagent. Okay, so here's our problem. We have 0.5 moles of aluminum, and we are reacting it with 0.7 moles of iodine to form aluminum iodide. What mass of Ali3 is produced? So underneath the problem, I'm going to go ahead and write what I have, 0.5 moles of Al, and I have 0.72 moles of I2 here. Okay, and I am looking for, not moles, I am looking for grams. Okay, grams of Ali3. Now, before any good reaction, we need to make sure that it is balanced. So let's go ahead and fill in these coefficients here. Without these, we have no mole-to-mole ratio, and that's a big deal. So make sure our equations are balanced, always. Okay, go ahead and write that in. So first step, to find the mass of Ali3, and I have 2 reactants, both with amounts of substances, I have to find a limiting reagent. So that's first thing first, 0.50 moles of aluminum. I need to figure out how much is produced. So on my stoichiometry diagram, boom, 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 I'm going to go from moles of aluminum, and I'm going to have to get into moles for Ali3, different compound, and then I'm going to have to go into grams. So this is a 2-step process. What is my mole-to-mole ratio? Well, I have 2 moles of aluminum for every 2 moles of Ali3. 2 moles of aluminum for every 2 moles of Ali3. Okay, so that gets that step done, but now I have to go moles to grams, which requires something called molar mass. So in every 1 mole of Ali3, I've calculated the molar mass for you. It ends up being 407.7 grams of ALI3. Silver, or aluminum, it's not super heavy, but iodine is 126, and we have 3 of those, so ALI3. Okay, when we calculate, I have the answer for you. We multiply everything on top, divide by bottom, and we get 203.9, and that's grams of ALI3. Okay, so now we got to go and do the other one. 0.72 moles of I2 on top. Same process, okay, except I have a different mole-to-mole ratio. Now we have 3 moles of I2 for every 2 moles of ALI3. So there's our mole-to-mole ratio. Now I got to go into grams, which is nice because I've already calculated ALI3. And it's 407.7 grams of ALI3. I had already calculated it in the first one, so I can just reuse it down here. When I calculate, I do have an answer. It's 195.7 grams of ALI3. So first of all, let's identify our limiting reagent. Which one has less? Which one produces less? In this case, it's this guy. So our limiting reagent is not ALI3, it's what it came from. So our limiting reagent, LR, you would say is I2. Okay, first part done. Okay, and here we are. Last step is going to be finding excess. How much is left over? We already identified that this guy is the limiting reagent, I2. But now we got to figure out how much aluminum is left over. How much aluminum is left over? Okay, so here we go. What we're going to do is we're going to take the amount of iodine that we started with, which ended up being, it was on the last slide, it is 0.72. We had 0.72 moles, and then we had like 0.50 moles. Okay, so we're going to start with the limiting reagent, 0.72 moles of I2. And what we're going to do is we're going to convert that into moles of aluminum. Okay, now I could go to grams, but that's an extra step, and we don't want to throw in an extra step. So I am going to convert moles of iodine into moles of aluminum using a mole-to-mole ratio, which ends up being 3:2. So 3 moles of I2 for every 2 moles of aluminum. So I'm not going to product. I want to convert how much aluminum I would need to react with that limiting reagent. Okay. So when I do that, I need to calculate, and the answer that I get is 0.48 moles of aluminum. Now, this is how much actually reacts with 0.72. Remember, this value 0.50 was we knew that it was extra, but now we're trying to figure out how much extra. So what I'm going to do is take that original 0.50 moles of aluminum, that's what I started with, way up there, and I'm going to subtract how much is actually reacting, 0.48 moles of aluminum. Do a quick subtraction. 0.2 moles of aluminum is in excess. And that is how you do it. Okay, we are finished with notes. The slideshow will have extra instructions on what to do for the rest of class. Thank you guys, and we'll see you tomorrow.